All right, so the first grouping operation we're going to talk about is group by. What this does is it groups a series or groups series using a series of columns or a mapper, like a dictionary or a key function. Um, um, and it applies that that function to the group and then returns the result as a series. So, for example, and this actually works in a two-step process. So, first you create the group by object, and then you apply some function. And typically, you can do these all in one step, but we'll see here how you can do it separately. So, what we're doing is we're taking the data frame, we're saying group by, and then computer OS or operating system. This is that column above where it's Windows, Mac, Linux, or NAN. And we're going to save that as this thing comp. So if we look at comp here, it just says pandas core group by object. So we have to then apply some function to that object, so we can apply the mean, or the average of the values. And so what happens is we've grouped this data frame by computer OS, and then we're going to have 3 rows, one for each of the values that had an operating system. That NAN row is dropped out because it doesn't have any value. So it's then going to group that. So it's going to group them, but then we have to say what we want to do with that. So we're going to get the mean. So it's going to take all the rows that say Linux and give the mean of each of these values, and it's only going to give us the numerical columns because it can't compute a mean on Y or N, for example, right? That this is still a column, and same thing with student. So student is actually still an object here. We didn't change that to an integer, and that's fine because those don't have mathematical value, right? We don't need to know the average of the student ID numbers, so that's fine. So we now have the average score on the command line, score on MATLAB, Perl, Python, and R of the different computer OS users. So you can try to divine some kind of pattern in the data. Maybe people that have Macs, seems like they have more Mac and Linux have more experience with the command line than Windows users. Of course, this is not a statistical test. This is just a description of the data. But that would be how we could get the mean of those rows. We can also get the standard deviation. So there's a number of functions we can apply to this group by object. Another nice one is count. So this just counts the number of values in that category. And so now you can see we do have the student ID numbers and whether they have a computer, because it can count strings. It can't compute standard deviations and means on those, but it can count them. So that's why we see more values from the count function than from the mean or the standard deviation. We can also group by multiple columns. So let's say we want to group by not just the computer operating system, but also the command line experience. So we can pass a list of those columns and then get the mean of that. So here I'm now applying the function inline, or like when I kind of link it to the group by. So in Python, if this is an object of type X, then whatever operations can be applied to an object of type X, I can link onto this command, right? So I can string commands together as long as I want, as long as the thing that is returned by that expression has some additional methods or functions that can be run on it, then I'm all good. So I can link these together. I can say data frame, it has the group by method, so I'm going to do the group by. That generates a group by object, and that group by object has function mean available to it. So I can run those all together in one single command. And now, so I've grouped by computer OS and then score on the command line. So I have now what's called a hierarchical index. So I have a level, like a first level index and then a second level index. And then I have now 4 columns in this data frame. And these are the mean scores of these combinations. So someone who has a Linux operating system and ranked 1 on the command line experience has these average values. We're starting to get pretty granular because this data table only has like 10 or 12 students in it, but you get the idea. So that index, it's a multi-index. So it has several. It has levels. This first level, which is has 3 levels: Linux, Mac, and Windows, and then the second level, which has 4 levels: 0, 1, 2, and 3.
So how do you call using the index, like the data associated?
Right, good question. So the question is, how do we get the data from this multi-level index? So we can first call a data frame, and then we can say, I think it's going to be, if I'm not mistaken, yeah. So if we wanted just this part of the data frame, we could use the loc Linux, and then I believe, well, one way we can then, let's try this. Yeah. So we can. Can you kind of see what's happening here? So we're first getting just this row, this Linux row, using the loc. Remember, the easiest way to do indexing is to, if you want to get a column, just don't put the loc part. Just put the name of the column in brackets. Or if it's, in fact, if it's just a alphanumeric column name, you can just do dot the name of the column. You don't, but the more standard way is to put square brackets and then in quotes you'd get. So, for example, let's do. So this is giving us a. So this is actually a series, if I'm not mistaken. Yeah. But it's a series that has itself has a multi-level index. You can always tell if it's a series or a data frame because a data frame shows up in this kind of formatted view, and the series just shows up as text because it's just a single column. But it's a column that has a double index. So you can index this in similar fashion. So you could do in this case, you would typically with series we will stack those. Right. Yeah, you don't need log because it only has one dimension. Yeah. Yeah, it did work, or okay. Yeah, so there's more than one way to pet a cat, I guess. I'm a vegetarian, so So you could also do, it's not working. I might need loc in this case. Or maybe I just need, I guess it's already,
It would just be like
yeah, maybe 1 would be the better example. Yeah, right. Right, yeah, sorry. Because that,
the
yeah.
comma also works.
The comma also works?
Yeah.
Okay, yeah, I just had the wrong. Yeah, so there's a lot of ways to do it. So, but yeah, so the main thing here though is that when you do generate this, yeah, so there's 2 points. There's when you do a group by with more than one thing, you're going to get a multi-level index, and then there's different ways to get the data out of them, using a multi-level index. I'm not sure. The loc nomenclature might be the better way to go, but it's a kind of a question. It's not generating any kind of warning, so I think it's fine. But another thing to point out is that maybe you don't want to have this multi-level index at all. You just want a basic data frame. So what you can do is when you do the group by, before we get the mean, we're going to get the mean, but before we do that, you can say as index equals false. By default, it's true. And so what this will do is those 2 columns that were previously those multi-level indexes are now just data, right? They're just, so this is a different style of showing the results. So you kind of need to know how this was generated. You need to know that like what was calculated. But this now is giving you these 2 columns are the different unique combinations of these 2 pieces of information. So you're going to have duplicate values in these 2 columns, but then these other columns will be the means. So you can see why the default would be more like this, because this is kind of more sensical with this kind of data. But okay, so we'll do the next one here, which is melt. So this is where you massage a data frame into a format where 1 or more columns are identifier variables, and all the other columns, which are considered the measured variables, are unpivoted to the row axis, and so you just have the non-identifier columns, variable and value. So this is hard to. The description is hard to kind of wrap your mind around, but let's just see it in practice, and I think you'll get a better sense. So here's our data frame, where we have the indexes are just numerical, and then we have student, computer, etc. And so we're going to do this pd.melt, so that's the function, and then we're going to first give this data frame. Second, we're going to give a list of ID vars, which is going to be computer has and computer OS. This is going to be linked to the how we're going to identify these rows or identify the data, and then we're going to have value vars, which will be the values that we want to see. And this is going to be a list as well, but we already defined this list as these 5 columns. So let's see what we get. So we're going to have a big data frame. It's going to have 70 rows, because it's going to have 1 row for all the different combinations of of the ID of these two ID columns and the then the variable column. So we have the so effectively it's not going to do any kind of computation. It's just going to give us the values of these different variables based on these values. So let's see if I can. Yeah, I'm going to change the. I'm going to copy this at the beginning, just so I can show you more detail. So now I'm going to see every row. So let's see here. So we had 14 students. And we have for every category 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 times. This is basically, it's taking all the data, it's not doing any kind of summary, and it's just reformatting it. So we see, we no longer have the student ID numbers. We just have, in this case, we just have whether they have a computer or not, what type it is, and then the value for each of these columns. So what this gives us, though, is it gives us a single column with all of that numerical data in it, which is then linked to these other things. So it might seem strange, but this could be useful, for example, if we wanted to plot, as we're going to see in a second, plot how the scores are different between the different people, because it's hard to do that if all the data are in different columns. So what we've done is we've taken all of those scores, put them in a single column, and then we have this other information that can be used in, for example, in Seaborn, which remember how Seaborn uses all this different contextual data for hue and et cetera, et cetera. So we can set x is going to be our variable. So we can do, yeah, x is going to be our variable here. Y is going to be our value, and then we're going to do the hue on computer OS. So this allows us to now see the value and the standard deviation of these 5 scores, because we set our x as the variable, which has this, which uses this score information, and then the hue is the computer OS. So this is a nice way, and this is called a point plot, and this is a nice way to see the data as it changes from looking at the different scores and how people do. And what I've done here is just showing you a different way to generate the same plot. So this is using just using the Seaborn function straight up, but I can also first create subplots, and then when I want to plot to those, this is just a 1-by-1 subplot, so just a single plot. When I want to plot to those subplots, I can just say in my Seaborn function, axis equals the name of the axis, and then I can do things like rotate the labels the way I want and so forth. So, so for example, I could set this to, if I wanted that, or let's do maybe 30 would look better.